Hello, welcome to our next lecture. In this series of lectures, we will start discussing application layer protocols, what it involves. So, most of the slides are from the authors of Gurus and Rose. So, as acknowledgement to them, we are saying, look, all these slides are mostly from them, but the good number of modifications have been done. These slides have been enhanced to give you more current information, but base slides still remain the same. So let's look at how did application evolve in the network, or actually how did network really even started. Starting at 1980, around that time, that is when the internet started. It is not the internet at what we see today in terms of browser. There was no browser, there was no web server, but we had TCP/IP protocol, and at that time, the mostly applications were exchanging email, and your instructor, presenter basically had these emails as well. I used it. Today we do a fine load, but at that time we used to have the file transfer protocol to download things up, and then we had, sorry, let me start again. Just give a minute. We had a login, there was no SSH, it used to be telnet, and what we basically look at blogs, posts to get the information. There used to be mostly called news groups, which has kind of become outdated, but that's the way to subscribe to news group, used to get information. So this mostly was text-based information, so even the images or files that we need to exchange, we need to encode them in some kind of base 64 encoding or UU encode mechanism, but all transfer used to be basically in a plain ASCII text. Around 10 years, that is when the browser started, and what we know today is so-called internet. Basically, first web server came around 1989-1990. Tim Berners-Lee. First web server was NCSA web server and NCSA Mosaic browser came in, and then the web started. And actually, since then, the internet keep moving by multi-scaling, and it basically took a leapfrog and became very popular. Around mid-90s, around 95 onwards, the e-commerce started, and primarily if you look at around that time, the internet got started using with peer-to-peer file sharing, instant messaging, and at that time, we used to have applications around that time which we used to call Microsoft Net Meeting. You had Yahoo Messenger. Those kind of meetings were there. And then after 10,000, around 2000, that is really when the rich internet applications came in. Skype became popular. Till that time, about Net Meeting or Yahoo Net Messenger, they are basically client server based. We'll talk about those little while. Around 2000, when Skype came in, it was basically free voice call to each other, and Skype was first peer-to-peer. That means that when two people talk on the Skype, the voice communication happens directly between the two and not via third party. Around 2005 is when the rich media applications or rich web, or you can say graphics, video started doing. And around late 2000, 2007, 2008, if you look at 2007 could be considered as the inflection point for the internet. That is when the iPhone was launched in 2007. Your Facebook, all those applications came around 2007, and that is where the internet really took off. So 2010 is when we got social computing apps. They become popular, whether you look at whatever apps you use today. And today the most popular app happens to be WhatsApp, but around that time you had Instagram, the Facebook, and other kind of things started around the time frame. Now today we have multiplayer games. Now the next decade, 2020 onwards, it is your guess what would happen, but certainly augmented reality could be one such choice, and net is going to get more and more interesting. And of course, now if you look at today, mobile traffic is a lot more than the desktop traffic. So you'll see new application coming up with mobile phone, and probably virtual reality, augmented reality, with cognitive computing, a lot more things will happen in the next decade. So our primary goal is, when you look at our TCP/IP stack, we had primarily 4-layer stack called application layer, transport layer, network layer, and the link layer. So first we study what goes in application layer, and then we get into the other layers subsequently. So essentially in application layer, we like to study how does application layer make use of transport layer services and what kind of architecture we need. So we look at there are two kind of architecture supported in the client share scenario. And today when you look at the web, when you browse a web, even though we may be accessing content from your college website, but good number of content like your images or other contents may be coming from what we call is content distribution network, or called CDNs. So Google has a one CDN, L3 Communications is another one, and we have a number of other companies offering you. The Akamai is one of the leading companies that gives you CDN delivery, and they basically keep a server. So all the rich graphic contents come from CDN services, even though main pages still come from the main website. So we'll study basically what primarily different applications are and what to communicate one application to the application on the other side, what kind of protocols are needed. So we'll look at HTTP, which is primarily the main protocol that's being used. So the major traffic of the net today follows HTTP, called Hypertext Transfer Protocol. Then, though today most of the people use browser-based email like Gmail or Yahoo, but initially it used to be client-based. So those of you who probably use Microsoft Outlook or Outlook Express or Apple's iMail, they still use mail protocol to send and receive. So if you're trying to access mail using offline, then mail clients. So SMTP, or Simple Mail Transfer Protocol, is a protocol to send mail. To receive mail by the client, POP3, Post Office Protocol, which is version 3, IMAP. So there's a minor difference, and we study these protocols. We'll get into those details. So my SMTP protocol is for sending a mail. My POP3 or IMAP are protocols for receiving emails, and that's what the protocols are. There, of course, we have other protocols called DNS, Domain Name Service. As a human being, we are very good at remembering names, but we are very poor at the numbers. For example, if you look at when you're in a class, you call your friends by name. You never call them by roll number. Hey, roll number 21, can we talk? You always call them names. But if you look at university system, your access, your numbers, they always use roll numbers. So machines are very good at dealing with numbers. Humans are good at dealing with names. So to map, because at the end, internet, when you use a browser, we use one machine, it has to talk to other machine. So addressing has to be done with the numbers, which is called IP addresses, but humans use the names. That's google.com or my website artwistki.com. So we need a service that, given a name, can it give me the respective IP address, and that is the service. It's called DNS. We'll study those protocols, and of course there are tons of other applications that we're going to study. And if we want to write our own applications, so any application that talks to the other one, it has to make use of called socket programming, or we make socket API calls, and we study them in a while. So let's look at some applications that we basically use. Email, though we use the browser based, still the client. Web, the browser. Web can still be accessed without using a browser. And we look at the tools in previous lectures. We look at the tools like curl, or we look at the tools like wget. These are the tools for offline browsing. We can actually even use NC Netcat to access the browser. As far as a web server is concerned, its only concern is if the client follows HTTP protocol, it will communicate and give the information. Then we do text messaging. We basically use WhatsApp, which is not peer-to-peer but client-server based. But there are other applications which can write, like Skype. There's text messaging. It can also do voice calls. When you manage a server, look at the clients, access, deploy something. So all the DevOps people need to access basically remote login, and we primarily use either SSH to log in, or to transfer a file we even do call SCP, secure cell is SSH, secure copy, we access those to do things up. We all use BitTorrent to do file transfer, file exchange, and those are the applications basically for file sharing. And of course the gaming is a big industry we look at. Today we do a lot of video watching. YouTube has become popular, so most good number of people we watch video on YouTube, or if you look at the video playing movie watching, Netflix, and now of course we do have what is called Amazon Prime. We look at Amazon Prime as well to watch that also works. So today look at the applications. We do Netflix or Amazon Prime to watch movies, our YouTube to look at any kind of scenarios, web applications, do social network applications like Facebook, Twitter, Instagram, LinkedIn. We do Google search. We also do Bing search, and there are tons of different network applications that come in. The beauty of the internet, or the main differentiator between internet-based application deployment versus telecom-based network application deployment is, in the internet architecture, if we need to deploy an application, all we need to do is deploy the application on some web server there, and our client will access this. And so only change we need to do is deploy the application on the server there, and then the client we open a browser. We can open a browser here and then access, and that's what it will basically work. The core routers, the intermediate routers all across, they really don't need to be aware of what is being accessed. They only transfer packet at the IP level. So look at how does my things really happen. So my client directly talks to the server. My clients talk to the server using the server in between. They just carry the packet. So all these routers, they look at the packet only from the up to network layer and transport layer, application layer. My whole network is agnostic to that. So essentially, we write programs. So for internet access, we write client programs. Today's world, we can basically say we use even browser. On server, we deploy our own applications. Or if you have a specific client, we write the client program there. And my network remain agnostic to or transparent to whatever applications we are trying to use. We don't have to write any software for intermediate devices. But in telecom network, even if you deploy any application, let's say voicemail, we need to make changes to all the devices in the intermediate, and that's why launching a new application telecom network takes years, whereas in the internet world, launching a new application, just download the application, deploy is probably a matter of hours and not more than that. In the internet world, there are two kinds of application architectures. One is called client server, another is called peer-to-peer. In a client server architecture, if we look at in the server, we need to have a server, and server recognized by a well-known address. Server has to be always on, and server has to be always on. It is always on host. It needs to have fixed address, a permanent IP address. It needs to have permanent IP address, and of course, if I need to scale, if there are too many clients accessing it, we can always deploy these servers on the data center and scale them up. So in client server, We have a server which always has to be on. It has to have a very well-known address which everybody should know. But client can come and go. Clients, these are my clients. Clients talk to the server. Clients don't talk to each other. Client can have any dynamic IP address. Client address doesn't have to be known to other. Dynamically, I can get an address as long as I can reach and server can respond back. That should be fine. Client does not have to be up and running all the time. Whenever a client needs to access service, I can open a client, run the client application, access and go away. But my server application has to be always on. It needs to have a fixed address, and that's the difference it basically makes. And again, in client-server architecture, clients do not talk to each other, but clients only talk to the server and not to each other. So in this client-server architecture, primarily clients make a request to the server. They don't talk, and our famous servers are like a web server, our mail server, our FTP server. This is what we do. And in this client-server mode, the server applications probably provided by the service provider or the application provider, like Gmail give us email, Yahoo, or we have a search by Google and Bing. Amazon gives you e-commerce platform, eBay or Flipkart, an Indian equivalent of Amazon. To watching movies, they give you Netflix. Redbox is another company that offers you movie service. And today the most popular app, your WhatsApp, where you text messages, share photographs, and even share videos. And we even do video calling, conference calling with this. Other is P2P architecture. That means there is no server there. We all talk directly between one client to the another. So everything is called peer. So there is no server which is always on. Systems come and go. And I'll talk to some system, whatever is available, nothing else. So I basically, as a peer, look for other peers, and whatever peers are available, I connect, talk to them, get service, and I may be in the network, and I may go away from the network. The beautiful part about the peer-to-peer network is they're self-scalable. That basically means the more the peers I get, the better scaling I get. In the client-server system, to achieve scaling, I need to launch more and more servers to achieve scaling. But in peer-to-peer architecture, the more the peers, the better scaling I do. I don't need to have another separate deployment. And peers can come and go, as you said, doesn't have to be all the time. Because peers come and go at their will, the managing the application with peer-to-peer really complex, because we don't know if something goes wrong, how to connect. If let's say peer 1 is transferring a file from peer 2 and peer 2 goes away, how do I get remaining files from other place? So the connection management, the content management becomes challenging, but we don't have requirement. It becomes much easier to deal with. So in the peer-to-peer architecture, I don't need a dedicated server. Peer talk directly to each other. There is no third party involved. And few examples are like we have a Skype, we have BitTorrent as the two applications we basically use. So BitTorrent to share files, Skype to make calls. Please note, WhatsApp is not peer-to-peer because peer-to-peer key requirement is at the time of communications, both peers should be up and alive. In WhatsApp, even though one can send a message, other will see another that comes in. So on WhatsApp, your message goes to some server and WhatsApp server, and then other follow one logs in, get the message. So WhatsApp is not peer-to-peer where Skype is peer-to-peer. So the major challenge with peer-to-peer is, as most of the internet user, we are at homes, our internet connectivity is asymmetric, so our download speed could be 10 Mbps, whereas upload speed could be 1 Mbps. So if I'm downloading is great, but if I need to upload, if I need to send files to other peer, my speed is much smaller. So the person who is seeing from me will get much poor response. So how to design applications where the user access language is asymmetric, and that remains a challenge, especially if you are doing P2P applications, the video sharing, file sharing, it becomes an issue. Other challenge is because it's fully distributed, there is no control on how many peers can come and go. Like servers, if government wants to shut down Amazon, it can simply order Amazon shut down these servers and Amazon has to comply with. But with millions of users all across, it's very difficult to control those. So implementing security or finding it out, some disruptive activity is really becomes a challenge because policy enforcement agencies or government agencies practically has no control over them. Other challenges, by nature we are selfish. I will have to download my content and go away. But what applications should be designing so that I person should have incentive to stay, because only if I stay in the network, then only other people get benefited. So how do I get incentivized so that I can remain in the network and other people get benefit? So we need to have some kind of incentive mechanism for user to stay in the network. So this is a brief view we discussed, and just to summarize, just work out, list 3 client-server applications that you use on daily basis, list 2 peer-to-peer applications that you use on your basis. For example, WhatsApp, BitTorrent, can you find something else? Also, you basically look at all the uses, all the applications mostly use TCP, which is considered reliable. Can you find applications that use UDP? And if my network service provider gives me guaranteed delivery, can we really use UDP instead of TCP? So next we'll look at basically how does my different application would work. We primarily start looking at HTTP, the protocols on.